Hey everyone, and welcome to our lesson on adding, subtracting, and multiplying polynomials. Polynomials are expressions with many terms. They can have one or many. That's why it's called a polynomial. And to add and subtract and multiply them, we have to follow different strategies, so I'm going to show you each one of those. When we're looking at adding them, we're going to look at the front numbers, the coefficients, and we just have to put those together for our like terms. Subtracting is going to be the same thing, but if we have a large expression that we're subtracting from another, first thing we want to do is distribute the negative sign, rewrite the terms, and then look for the coefficients. Finally, we're going to check out multiplying, and to do that, we have to have a little bit of patience because since these have many terms, we're going to be distributing every term in the first group to every term in the second or even third group. But having patience and being very precise with that, we can get that done. FOIL will be used a lot of times for those because we'll see two binomials that need to be multiplied. And that is the process of multiplying first terms, outer, inner, and then last. Alright, so let's take a look at adding first. Remember to add, we are going to look at the coefficients and like terms. And one thing I want to mention about like terms is that we're only looking at like terms if we see the exact same variable and the exact same power on that variable. So for instance, an x squared would not be a like term with an x cubed. It's got to have the same power. Let's take a look at an adding example. What we need to do is we need to scan through for our like terms. So remember, we're looking for same variables with the same power. So as I scan through, I see 1x to the fifth, no more of those. And then I'm going to go through and look for the powers of 4. So see a couple of those here, one over here in this other expression. And you want to pull in that sign in front of the term with the term. So negatives will come along with both of those. Alright, scan on through and you're going to look for powers of 3. Don't see any of those. No powers of 2, but we do have a couple of powers of 1, x. Okay, those are here. And then a couple of just constants. Get those identified here. Alright, so we are ready to add. So we're just going to pull these down, adding the coefficients. So we've got x to the fifth. Next was our powers of 4. Negative 7 minus another 1 gives us negative 8. Okay, moving on to the powers of 1. Positive 3 plus another 9 gives us 12 x terms. Then I have my 3 plus my 5, which gives me 8. So I believe this will be our final answer. And it's always good to start with the highest power and work your way down because that's called standard form. So you can go ahead and get that in standard form as you work. Alright, subtracting. So what's the difference here? The difference is we are going to take the subtraction symbol and distribute it before we start so that we can make sure we have every sign correctly adding together. Okay, so I'm going to just rewrite this part over here to the right. This will become minus 10 minus 5x cubed and plus 4x squared. And now really I'm just adding, just like we did in the last example. So I'm going to add using the like terms and the signs that go with the numbers. So scan through, starting with the highest. Let's look for the powers of 3. We have these two. And now we want to find powers of 2. We do have a couple of those. And we do have a couple of constants. And make sure we get all these signs coming with them. Alright, now that we can clearly see what needs to go together, let's go ahead and add these up. So our highest power was the power of 3. I've got 2 minus 5. You can see those in green. 2 minus 5. So negative 3x cubed. Negative 3 of those. Another helpful thing is to kind of mark them out when you're done. And that helps you see what you have left. The powers of 2 coming together next. 3x squared plus 4x squared. That gives me 7 of those x squared terms. And then my constant numbers, I've got 8 minus 10. That's negative 2 minus another 7. That's negative 9. Okay, so we have a nice standard form polynomial here, simplified from this subtraction problem. Alright, lastly we want to look at a couple of multiplication examples. We want to make sure we get every term in the first group multiplied by every other term in the second group. And this time we just have one term in the first group, so it'll be sort of easy. We just want to distribute that across to each term in the second group. So we're just going to go ahead and start multiplying. We're going to multiply the coefficients, and then remember, when you're multiplying like bases, you're supposed to add the exponents, so that's what we're going to be doing with the powers. So we've got 3x to the 2 plus 4, which is 6. Next we have 3 times 5, 15. X to the 2 plus 3 gives me 5. And then minus, because of this minus 2, 6x squared. He did not have an x on him, so we're just multiplying the numbers and bringing down that x squared. Final answer in standard form. There we are. All right, next multiplication example, I'm going to show you FOIL. That's a process used to multiply two binomials, and it's called FOIL because we're going to do the first terms, then the outer, then the inner, and then the last, so you can remember it using that acronym. So first terms, I'm going to do 5 times 3x squared, 15x squared. Then I've got to work my way to the outer. Then I'm going to come into the inner terms, negative x times 3x squared, negative 3x cubed. So I've got x to the first times x squared. And then the last terms, negative x. Alright, so the only thing we could do here is put it in standard form, which is greatest to least in order of exponent. So I would pull my x cubed term first, then comes the x squared, x to the first, and my constant. And we made it. There's our polynomial in standard form. Alright. So here's the one we need to have patience with. We've got 3 expressions. Each one needs to get multiplied by each other term. So the best way to tackle this is to go ahead and do 2 at a time. Then you can take your new expression from that and carry it over to the third expression. So I'm going to do these first 2 here. So 2x times x, 2x squared, and then 2x times minus 3. That becomes 2x squared minus 6x, and I'm done with these two. So now all I have to do is carry that one to my second expression. So we're going to use FOIL again. First, outer, inner, last. Let's get a different color for that. So first 2 terms gives us 8x to the 4th. Outer gives us 2x squared. Working our way to the inside, minus 24x cubed. And last, minus 6x. Only other thing we could do is put it in standard form, so let's work on that. Gotta look for your highest power and work your way down to the lowest. I believe we just about got it. That wasn't too bad. Nothing else can go together here. You always want to kind of check that out and make sure nothing else could come together in the end, because if it can, you need to add those together. And this concludes our lesson on adding, subtracting, and multiplying polynomials.